Hello everyone. Now this is the first chapter of class 11 and this is the first lecture of this class. So in this chapter, in first lecture, we will cover the theory part of the set theory, and after this class we have the problem solving sessions, and there are two problem solving sessions. At least we will complete 20 to 25 questions in the next two sessions. So this is purely based on the theoretical portions. So now we are going to start. First of all, what is set? Set is a collection of well-defined objects. So here is main term that is used in the definition of set is a collection of well-defined objects. So what is the meaning of well-defined? Well-defined is the property by which we can justify or we can determine whether an element will be in the collection or not. Okay, now for example, if I am writing, generally the sets are denoted by the capital letter A, B, C like this, and its member, or we call it is elements, is denoted by the small letter, suppose A, B, C like this. Okay, now so if I say A is a set of first 5 prime numbers. First 5 prime numbers. So in this collection we have 2, 3, 5, 7, 9, 10, 11, this one. Okay, now if I say B is a set which contains set of all vowels of English alphabet. So this will contain A, E, I, O, U. Okay, now so when we want to use that, we want to say that 2 is the element of A, we can write in this way: 2 belongs to A. So here read as 2 is in A, or 2 belongs to A. 2 is the element of A. Okay, now but in this set you notice that 4 is not there, so we should write 4 does not belongs to A. That means 4 is not in A. 4 is not the member of A, or you can say that 4 does not belongs to A. Similarly, B is the set of all vowels, so you can say that A belongs to B, E belongs to B, but here you can also say that X does not belongs to B. So I think from here you can understand that what is set. Set is a collection of well-defined distinct objects. So, and generally set is denoted by the capital letters, and member of sets or element of set is denoted by the small letters A, B, C. Okay, now we use this symbol. This is called belongs to sign. This is known as belongs to sign. This one does not belongs to. Okay, or you can write in this way: does not belongs to. Okay, now next is a representation of sets. We generally use the roster or tabular method. There are two ways to represent the set. Second one is property or set builder method. So what is roster or tabular method? First one we are going to describe. If you write all the elements of the set and use they separated by the comma sign and ends with the curly bracket. So in this method we write all the elements of the set. For example, if you are writing A is a set which contain first 10 natural number. So set of first 10 natural numbers. So in this method, roster method or tabular method, we write all the elements, we list all the elements here, and they are separated by the comma sign, and we use the curly brackets to in both sides to denote the collections. Okay, now similarly, if you write B is the set of all the month of the English calendar, so it will be January, February, like this we have up to December. Okay, now in this way we can write in the roster or tabular method. Property or set builder method is the method. In this method, what we do, we should write the property in such a way so that this property will give all the elements of the set. So here generally if you write a set A, you can write in this way, set of all x, such that we have to mention some rule, some property, so that we will get all the x. So property of x we have to state. For example, if I take a set, suppose C, which is set of all x square, such that x belongs to integer z. So this will indicate if x is 0, then we have 0 square is 0, then 1 square is 1, 2 square is 4, plus minus 3 square is 9. In this way we have these sets. Another thing, suppose if I write set D, which is equal to set of all x, such that 1 lesser than equal to x, lesser than equal to 4, and x belongs to natural number. So this will indicates we have the elements 1, 2, 3 and 4. Okay, now so in set builder form we have to write the property which gives us all the elements of the set. Now coming to the finite set and infinite set. If the number of elements in a set is finite, it is called finite set. Number of element is finite. Number of elements is finite. For example, suppose A is a set. When you throw a dice, all the outcome we are taking. So therefore we have, when you throw the dice, you have this outcome 1, 2, 3, 4, 5, 6. You can count how many elements are there. So this set is known as the finite set. Number of elements should be finite. So now in case of a finite set, the number of element is called the order of the set. Number of elements present in A or in any set, number of elements present in a finite set. Number of element present in a finite set is called order of the set. Or you can say that cardinal number. Order of the set, or you can say that it is the cardinal number of the set. So here you notice that number of element present in the set A is 6. So you can say that number of elements in A denoted by n of A. Same things you can write in this way, mod of A, which indicates the number of elements in A for the set A. Or you can write in this way, cardinal number CARD of set A, which is equal to how many elements are there? 6 elements. So it is only possible when your set is finite. For the infinite set, we don't have the cardinal number. Cardinal number is not defined. So what is infinite set? Infinite set is a set which contains infinite number of elements. So number of element is not finite, infinite number of element presents in the set, infinite number of elements present in the set. For example, if I take a set of natural number which contains 1 2 3 in this way up to infinity, so we can say that the number of elements in the set is infinite, it is not defined. So we cannot calculate the cardinal number or the order of the set natural number. Okay, na? Similar way, if you have some set like capital X which is equal to close bracket 0 to 1, so how many elements are there, we don't know. Okay, na? Now next is singleton set and null set. What is singleton set? A set containing one element, a set containing one element, a set containing one element is called singleton set. For example, if I have a set A which contains, suppose, a number 5, it is a singleton set. What is null set? Containing no element. In this set the number of element is 0, there is no element in the set, it is called null set. It is generally denoted by 2 curly bracket, or you can say that it is denoted by 5. Okay, na? So if I ask you for the singleton set, what is the cardinal number? Cardinal number is 1 for the singleton set. What is the cardinal number of null set? Cardinal number of null set is 0. There is no element in the null set. Okay. Now coming to the subset. A set A is called the subset of a set B if every elements of A is the element of B. Every element of A belongs to B. Belongs to B. Every element of A. If every element of A is the member of B, then we call A is the subset of B. A is the subset of B. Okay, now in the same sense, in this situation we called B is the superset of A. B is the superset of A. So this is the notation of subset. So this notation we use for the subset. We use for subset. Okay, now take one example. Suppose when we have one set like 1 2 3 4 5 and 6 elements are there. Okay, now and B is a set which contains, suppose, 1 2 3 4 5 6 7 8 9 and 10. So you notice that every member of A is the member of B. Every member of A is the member of B, है ना? Every member of A is the member of B, so we called A is a subset of B. Okay. Now take one more set. Suppose if I am taking C which contains 0 1 2. So you notice that 0 is not present in A, is also not present in B. So we can't say that C is a subset of B. So in this situation we should write C is not a subset of B. We can also say that C is not the subset of A. So this notation we denote for not subset. Not subset. Not subset. Okay, now later we see that in the Venn diagram, if it is a set B and if A is the subset of B, then we denote A like that. A is a subset of B. Okay, now I hope this part is clear to all. Coming to the next, equal sets. Two sets A and B are called equal set if every elements of A is the element of B. as well as every elements of B is the element of A. So every element of A belongs to B. Every element of B belongs to A. Then we say that A and B are equal set. For example, if I take like that, A is a set. Suppose set of all the letters of the word follow. So in follow word, the letter that are used, from those letters we will form the set A. So that means one is F, one is O, another is L, and then W. Follow. Okay now. And B is a set which contains set of all the letter of the words wolf. Set of all the letter of the words wolf. So in this set we have W, O, L, F. So you notice that A set and B set, every elements of the A, F is present here, O present, L present, W present. Here also W present here, O present here, L present here, F present here. So we can say that A and B are equal sets. Now next is proper subset, superset and universal set. So what is the meaning of proper subset? A is a subset of B. We just read this definition. A is a subset of B at the same time and A is not equal to B. So this is, in this situation, if A is a subset of B and A is not equal to B, then we call that A is a proper subset of B, and we denote in this sign A is a proper subset of B. So in case of the subset, you notice that in case of a subset there is one sign, that is equal to sign present. Okay now, but in case of a proper subset, equal to sign is not allowed. That means in the set B at least one element present, in the set B in the set B at least one element present which is not in the set A. For example, you can suppose A having 1 2 3. So B is 1 2 3 4, at least one element extra present in B, then the proper subset concept is come to the pictures. That means A and B can never be equal. Every elements of A belongs to B, but there is at least one element in B which is not present in A. Superset: if A is a subset of B, then B is called the superset of A. If A is a subset of B, then B is called the superset of A. Okay na? Superset of A. That means A contained in B or B contains A. Universal set: when we discuss a problem of a set theory, then we think that all the elements of sets that we are going to discuss, they belonging to a bigger set. That bigger set is called the universal set. For example, suppose I have a set x1 which contains the element -1 0 and 1. I have another set x2 which contains 1 2 and 3. I have another set x3 which contains suppose 4 and 5. So if all the elements of these sets belong to some other sets, like we have a bigger set which contains all the elements of these sets, like -1 0 1 2 3 4 5. So this is called the universal set, which contains all the elements of the given set. So all the elements which are present in different sets, that elements present in a bigger set. So the set which contains all the element is known as the universal set. For a particular problem, the universal set is fixed, but we can define a universal set in a different way. Suppose if you add 2 more elements here, then you will be that set, but for a particular problem, universal set we have to fixed. Okay, now next is set of sets and power set. What is the meaning of set of sets? Suppose A is a set which contains the element 1 and 2. Now if I make the another set which contains the element which are again a set. Set of set means a sets whose element is also sets. For example, from here I am taking 1 and put here. From here I am taking 2 and put here. So I am getting a set which contains the sets. So set of set means a set which whose elements are also sets. So this B is the set of sets. Okay, now coming to the power set. Power set is very important concept which is required to solve the problem also. Power set of a set A is denoted by P of A, power set of A, and this is the power set of A is the set of all subsets of A. Okay, now so if A is 1 comma 2, then the power set of A is first we take element 1, then we take the element 2, then we take 1 and 2 together. So this is also a subset, and we know that phi, that is the empty set, is the subset of every set. So again we have to take phi also. So here you notice that power set of A contains the total 4 element. The number of element present in A is 2, and the power set of A contains 4 elements. So you can write in this way that cardinal number of power set of A is equal to like 2 power 2, that means 4. Okay, now I think concept of power set is clear. Next, if n of A, that is the cardinal number of A, is n, then the cardinal number of power set of A is 2 to the power n. So just in the previous example we noticed that when A contains 2 elements 1 and 2, then the power set of A has the cardinal number 2 power 2, that is 4. In the just previous slide we saw this result. If A contains 2 elements, then the power set of A contains 2 power 2, that is 4 elements. So similarly here, suppose this set A has only 1 elements. So its power set of A has how many elements? Phi is the subset of every set. So we take phi, then we take 1. So therefore 2 elements. So you can write in this way, the cardinal number of power set of A is equal to 2 to the power 1. 2 to the power 1, because in A there is 1 element. Now coming to the null set. If it is a null set, that means it nothing. It contains no element. So its power set contains what? Power set of phi. Because we know that phi is the subset of every set, so it will contains phi. So that means 1 element. So this will imply the cardinal number of power set of A is equal to how many elements are there? 0 elements. So 2 to the power 0, that is 1. So power set of phi contains 1 elements, and that is phi only. So if 2 elements, then we have 2 square. If suppose A is 1, 2, 3, A contains 1 to 3 elements, then power set of A contains how many elements? 2 to the power 3, that is 8 elements. So how we can calculate 8 elements? Phi, then we will take 1, 2, 3, then 1 comma 2, 1 comma 3, then 2 comma 3, and then 1 2 3, 1 2 3. So how many elements? Count it. 1 2 3 4 5 6 7 8. So we have here, that means power set of A contains 2 to the power 3 elements, that is 8 elements. Okay, now what will happen if we consider this power set of A? So from here we have the clear picture that if n of A is n, then its n of power set of A should be 2 to the power n. Okay, now so if power set of A we are going to count, so it will be, in power set of A how many elements? 2 to the power n elements. So if 2 to the power n you call x, then p of that will be 2 to the power x, that means 2 to the power x, that means 2 to the power n. So if there is 2p, there will be 2 times 2 to the power 2 occurs. Similarly, power set of sorry, A, so this will be like this one, 2 2 2 and the n. N is the number of elements present in the set A. Now some important conclusions. We know that phi is the subset of every set, because we know there is no element which present in phi we can show that it is not coming from the set A, because if you want to show that A is not the subset of B, then you have to show some element present in A which is not present in B, but it is not possible in case of phi. You cannot find a single element which is present in phi but not present in A. So that's why in a reverse, that means in this logic we can prove that phi is the subset of every set. Okay, now next is A is a subset of every set, that means every set is the subset of itself. Coming to the third point, if A is a subset of B, at the same time B is a subset of C, then naturally A will be the subset of C. Okay, no need to prove, these are very simple. Now this fourth result also, if A is a subset of B, every elements of A belonging to B, at the same time every element of B belonging to A, then A is equal to B. This result is very important. When you want to prove something A equal to B set, then you have to show that these two things. This result is very important for the problem solving. If you want to say show that two sets are equal, if you want to show that two sets are equal, A and B, then you have to show simultaneously two things. Number one, you have to show A is a subset of B, at the same time you have to show B is also the subset of A. This one. A is a subset of B, then you have to show B is a subset of A. Now next is Venn diagram. In Venn diagram, what is actually we will do, it is the pictorial representations, that means in the picture form we are going to represent the set. Generally we use the rectangle for the universal set, and for any set we use the circle. For any set we use the circle, and for universal set we use the U, that means rectangle. Okay, now so now we for using the Venn diagram we can do the algebra of the set theory very easily. So coming to the one by one union, so using the Venn diagram we can represent the union of the set very easily. And what is the meaning of union of two sets? So union is, if you take two sets A and B, so A union B is the set of all X, such that X belongs to A or X belongs to B, X belongs to A or X belongs to B. Okay, now so now in diagram you can show that it is the universal set, it is A set, it is B set, A set and B set. So this whole thing is the union. So A union B is denoted by the shaded part. This is the A union B. What is A intersection B? If you take two sets, so A intersection B is denoted by this sign. It is just like, you can say that cup. This sign you can say that it is the union sign, or in your To memorize it, it is just like look like a cup. Okay, now A union B, it is the sign of union. U for union. Okay, now U for union. So A union B is this one. So if it is cup, then you can say that it is cap. Okay, now this is the sign of intersection. So A intersection B is the set of all element X such that X belongs to A and at the same time X belongs to B. So that is the difference between the union and intersection. Intersection means your set, your element X belongs to both the sets. Okay, now so here is the diagram for the intersection. This portion we are taking which is common in both. This is set A, this is set B, and this is the common portion. We say this one is the A intersection B. This is the shaded part. Okay, now A intersection B. Okay, now coming to the difference of the two sets. So difference of two set is denoted by A difference B in this way or A minus B. So A difference B, from here you notice that it is the set of all X such that X belongs to A and at the same time X does not belongs to B. So you have to take those element which belongs to A but not in B, which belongs to A, or you can write in this way, which belongs to A but not in B, not in B. So which is the solely elements of A only. So now the diagram will be like this one. Only the part of A you have to consider. This part is A, this part is B. So now this is A, this one is B. This portion is known as A minus B, where the elements of A only present, no elements of B is present. So this part you can say that B minus A. This part you can say that B minus A. This part is say that B minus A. So you naturally notice that A minus B and B minus A are not equal. A minus B is not equal to B minus A. Okay, now so take one example so that we can understand union, intersection and difference. A is equal to, suppose I am taking 1 2 3 4 5 and 6. B is the element, or you can say that 3 is missing, 3 missing. 1 2 4 5 6. B I am taking like this one, 2 4 and 6. So now if you take their union, A union B, so it will be what? The elements you have to take which is present either in A or in B. Repetition of the element is not required. 1 present in A you have to take, 2 present you have to take, 3 is not present in both the set, not required, 4 present, 5 present and 6 present. Okay, now coming to the A intersection B, so only the common elements you have to take. So in both the sets you notice that 2 4 6 present, 2 4 6. So 2 4 6 is the common element. Now A minus B, from A subtract the elements of B. 2 4 6 you have to subtract 2 4 6, 1 5 left. So 1 and 5 is the element of A minus B. Now calculate B minus A, from B subtract the element of A. Common element you have to subtract 2 4 and 6. If you subtract 2 4 6, nothing will left in B. Is it clear? Here you notice that why the 5 will come, because B is the subset of A. So we have the 5. Okay. What is the meaning of complement? Complement of a set A is denoted by A complement, or you can write as A dash, or you can write A bar, which is the set of all X such that X belongs to the universal set, but X does not belongs to A. Not the element of A you have to take. Okay, now so that means if you have this one which is the universal set U and it is your set A, so outside of this set, this shaded portion we call the complement. This shaded portion is called the complement. So this is A complement, shaded portion. which is not the element of A. That means all the element outside of A. To take one example of the universal set, suppose U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and your set A contains 2, 6 and 10. So what is A complement? A complement will be except 2, 6, 10. So 2, 6 and 10 you have to remove from the list. You have 1, 3, 4, 5, 7, 8, 9. This is the complement. Okay now. So you notice one thing, if you add A plus A complement, that means in set theory A union A complement, you will get the universal set U, and there is no common things between these two sets. A intersection A complement is null set. There is no common element between its complement and the set itself. Okay now. Laws of algebra. Some important laws of algebra. Number 1, it is known as idempotent law. If you take any set A and if you take the union with A, you will get A. If you take any set A with intersection itself, you will get A for any set A. Now commutative law. So you know that union property is commutative. A union B is same as B union A. A intersection B is same as B intersection A. Associative property for 3 set, if you take A union B union C, which is same as A union B, then union C. Similarly, it is happened for intersection. If you take A intersection B intersection C, so it will be same as A intersection B and then intersection C. Distributive property, it says that number 1, A union B intersection C. A union B intersection C, it is A union B intersection A union C. Now if you have A intersection B union C, so it will be A intersection B and union A intersection C. By the Venn diagram, very easily you can do this. Now coming to the De Morgan's property, from here I am writing. So De Morgan says that if you have A union B complement, it will be A complement intersection B complement. Second is A intersection B, its complement, it will be A complement union B complement. That means when you take the complement, you have to change the sign. Union becomes intersection, intersection becomes union. So if you want to prove this result, so I am going to prove only one. First one by the Venn diagram. So taking the left hand side, I am choosing this one. This is my A set. This one is the B set, A and B. So its union will be like this one. No? This is the union, shaded part. So A union B is the shaded portion. Now if I am taking their complement, what will happen? This is A set, this is B set, and A union by B already I shaded here, but I want the complement. So A union B, its complement will be which one? This portion outside of the set, this one, this one. Okay now? Okay. So this is the shaded portion of A union B complement. This is left part I have done here. Now coming to the right part. So this is A set, A set. So if you take A complement, so it will be the outside of this one, A complement. Now similarly, if you take B complement, so this is set B and its complement is the outside. Okay now? Now if you take their intersection, if you take their intersection, what will happen? Neither A nor B. If you don't want A, if you don't want B, if you take their intersection, what will happen? A intersection B if you are taking, then what will happen? A complement intersection B complement. Okay now? So A complement means which part you have to take outside of A. Then you have to take B set and its complement, that means whole part outside of B, and you have to take the common portion. So when you take the common portion, what will happen? This part you are getting now. A complement intersection B complement. This is the shaded part. Okay, or if you want, you can do one more thing. Okay, no need. You can do one more thing here for more clear ideas. You can do one thing. Suppose if you take here A intersection B, so that you can understand what is going on. So A complement means outside of A. So now this is A and this is B. This is A set, this is B set. So you have to take A complement. That means you are going to calculate this portion, A complement, this one. This one is the A complement. Okay, now next, if you want to take B complement, so B complement you have to take outside of B. So I am drawing this one vertical line outside of B, this vertical line, this vertical line. So you notice that the horizontal line and the vertical line, whether they intersect, this portion is outside of this one. Here only you have vertical line, here only you have horizontal line. So their intersection will be this one outside of the set. Okay, now so in this way, by taking the Venn diagram, you can very easily find out all these results. You can show that. Now coming to the identities law. Identities laws is what? If you take the universal set and any set A with the universal set U, you will get, after taking the union, U will come. Any set A intersection with the universal set, you will get the same set A. Now if you take phi, so A intersection phi, A will happen, A will come, because phi is the subset of every set. A union phi, you will get the A, because A intersection phi, smaller is phi 1, smaller is phi. A intersection phi, you will have phi. A union phi, you have the A set. Okay, now these are known as the identities laws. What is the complement? Complement laws is what? Suppose if you take A complement and it's again complement, you will get A. Okay, now next is, if you take universal set, its complement is phi. If you take phi, its complement is universal set. So these are small things you have to remember. Now what is duality? In set theory, some results are there. If you interchange between the union and intersection sign, you from one result you go to the another result. For example, if I am taking here A union B intersection C, so I have A union B intersection A union C. Now union become intersection. If you take interchanging between union and intersection, union become intersection and intersection sign become union. In this result, if you put, you will get A intersection B union C, which will be A intersection B union A intersection C. So this law is known as the duality law. Now coming to the most important part, how to calculate the number of elements in a set. Suppose this one, we have n of A union B. So total number of elements in the union of A and B is total number of elements in A plus total number of elements in B minus total number of elements in their common portions. So coming to the proof of this result, the proof is very easy. With the help of Venn diagram, you can prove it. Suppose this is a set A, this is a set B. This portion you know that A minus B. This portion A intersection B. This portion is B minus A. Okay, now. So you notice that these three are disjoint set. These three are actually disjoint set. Okay, that means there is no common element among the three sets. So A set I can write as A minus B union A intersection B. So therefore number of elements in A should be equal to number of in A minus B plus number in A intersection B. Yes or no? Okay. Similarly, we can write from here B minus A and A intersection B is the whole set B. So similarly, we can write number of elements. What I am writing P. Okay, it will be N only. Okay, now. Okay, it will be A. Sorry, this will be A, not P. Number of elements in the set. So A set we can write in this way. So number of elements in A will be number of elements in A minus B and number of elements in A intersection B. Now number of elements in B, similarly we can write number of elements in B minus A and plus number of elements in their intersection. So I am calling this is the result 1, this one is the result 2. Now coming to the whole union. So A union B is same as A minus B union A intersection B union B minus A. So you notice that all three sets are disjoint sets. Okay, now all three sets are disjoint sets. So number of elements in A union B, disjoint set means there is no element common in all three sets, or if you take any two, there is no common elements. So n of A union B will be equal to n of A minus B plus n of A intersection B plus n of B minus A. Now n of A minus B I can calculate from here, n of A minus of n of A intersection B, n of A minus n of A intersection B. Next is n of A intersection B. Number of element is B minus A, I can calculate as total number of elements in B minus their intersection. So total number of elements in B minus their intersection. So if you cut these two, you will get the required result. Total number of elements in A, total number of elements in B minus total number of elements in A intersection B. The third result is the consequence of the first one. What you have to do, you consider that this one you consider as the X set. Now this is your X and union C. So you should apply this result repeatedly 2 times, you will get the this third result. That means this one you will obtain. Okay now. So this is your homework, try to solve this one. So our theory portions we have completed here. In the next class we will do the problem. So here one thing I want to mention, that is disjoint set is what, when their intersection, two set having the intersection null set is called the disjoint set. So from the next class we will start the problem solving classes of the set. Bye, have a nice day.